Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello and welcome back to this amazing channel Geeks for Geeks Practice. This is Abhinav and today we are back with our next problem of the day, which is another coin change problem. So guys, the problem today is something based on dynamic programming. It's a very classical problem of dynamic programming. Something similar to knapsack problem 2. Okay, it's something similar to knapsack. So let's solve that problem. Hi Risit, hi Matbar, hi. So first of all, before starting, please let me know if I'm clearly audible and visible to you all, so that we can start. Guys, am I clearly audible and visible? Great. Let me add the screen here and let's start today's class. So guys, the problem is another coin change problem, and let's see what the problem says. So guys, the problem says that there are some coins given to you, or specifically there are n coins that are given to you, and what you have to do is that for these n coins, you have to take some coins from them, and every coin has an infinite supply. And by doing this, what you have to do is you have to make your sum equal to the target that you have. You have to make your sum equal to the target. And one more thing here is that your value of k, your value of k should also, like, the number of coins should also be exactly equal to k. So that's the basic thing. So this is the n, k, and the target given to you. What you have to do, you have to take some k coins from this list, some k coins from this list, such that their sum is equal to the target. That's all. Is it clear? Okay, is it clear? Great. So let's say, guys, let's say here in this particular case, if you will see, we have this thing 110, 586. So this is the error that is given to us, and let's say they are saying our target is equal to 11 and k is equal to 3. Target is 11. No, 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 no. Total number of coins should be k. Total number of coins should be k. Got it? It's not like the same denomination. The total number of coins should be k. Okay, that's it. Fine. Now see one thing. See one thing. What we are having now here is that, let's say we have three coins and our target should be 11. So guys, what I will do, I will first write a recursive function, and let's say I am currently at ith coin. So guys, for the ith coin, how many possibilities we have? We have two possibilities. We have two choices. Either consider that ith coin means take case, or don't consider it means not take case. These are the only two possibilities that we are having. First possibility is the take case. Second possibility is the not take case. Simple. Either take it, either not take it. That is the basic two possibilities of your problem. Got it? Either take it, either not take it. So when you will take the ith coin, so what will happen? Your target will decrease with its value where you are, high linkage, and your k will also be decreased. K decrease means you have taken one coin. Target is decrease means you have taken that much amount of money. And in not take case, nothing will change. Nothing will change. Because you are not considering that particular coin, and you will simply move to the next coin. You will simply move to the next coin. These are the two possibilities that we have. Am I clear? Right? For a particular coin, we have two possibilities. Either consider that coin or don't consider that coin. That's all. And this is how we will do the solve problem. This is how we will solve the problem. So देखो, what I will do, guys, we will write here a recursive function. Okay, we will write a recursive function. So I will take a function that will return boolean only as they want, and let's name it recursion. Okay, simple recursion function is there. So this function will take everything what is given here, everything is required. We will have one more thing, int I. So what is int I? Int I is nothing but the ith index where we are currently. So let's say we are currently at this particular index I. Okay. So because it's a recursive function, we have some base cases, but I will not talk about base case now. First, let's talk about the recursion case, the recursive cases. Okay. First, let's talk about the recursive cases. What are the recursive cases for this particular problem? So guys, the recursive case is very clear that we have two recursive cases. We have two cases basically, either take it or not take it. So first, let's take a not take case. Not take means you are not considering the coin at ith position. You are not considering the coin at ith position. So what will be your not take case? Not take. So guys, not take case will be very simple. Will be very simple that you will not consider that ith coin, and you will simply move to I plus 1 coin. You can simply see that not take cases I am calling for recursion. Every value will be as it is. N, K, target, coin, सब कुछ वैसा ही है. Just I is changed to I plus. Now let's consider take case. Take means when you are considering that particular value. So your take case will be, guys, in your take case, what will happen? That I will remain as it is because you are considering that coin. Now, in your n will also be as it is by n, like size of the array will be as it is. K will decrease by 1. Why? Because you have taken one coin. So now k coins are not left. Like overall, you have to take k coins. Overall, you have to take k coins. But because one coin is taken, which is the ith coin, so I will make it k minus 1. And my target will be also subtracted by ARR of I. That simply means that previously our target was this target, but now I have taken a coin at ith index, so my target will be decreased and my coins will also be same. My I is still IY because, guys, I can take same coin again and again. If you know one thing, according to the problem, what they are saying is that I can take this ith coin again and again. I can take this ith coin again and again. So once I have taken a coin, I will again check for the same coin, whether I can take it again or not. You can see there's an infinite supply of each coin. Okay, so this is the take case and this is the not take case, and we will simply return, or I can say my answer will be simply take or not take. Like if any of 2. If any of 2 will is true, my answer is true. And then I will return answer. Is this much part clear? Is this much part clear or not? Clear? Great. Now let's see what will be the recursion cases. What are the recursive cases that we are having here? Okay. So first, let's check the false recursive cases. When the output will be false, when the output is not clear. Okay. So we want our target to be zero. Like we want that much coins such that they are subtracted, and at the last my target should become zero. Means the whole target is contained, and my k should also become zero. Okay, I want these two things. At the last, my target should become zero and my k should become zero. Hello guys, am I audible? Like, is it clear? Clear? Hai? Okay, great. Now guys, two cases are there. If my target is less than zero or my k is less than zero, means obviously answer will be false, because I don't want any one of that to be zero. I want my at the last my target as zero and k as zero. But if they are less than zero, I don't want it. Okay, now next is when my I will reach the end. So when my I will reach the end of the array, means all the coins are considered, they are taken or not taken, whatever. So if we have reached the end, so if my target will become zero at the last, and target is also zero, and k will also become zero, means I have taken k coins whose sum is equal to the given target. If both the conditions are true, that means I will return true. Else again I will return false. And these are the two base cases that we are having. I hope it's fine. Now I will simply call this recursive function here recursion, like I will return recursion. I will start from zero. I will start from zero, from a zero index. Like first, we'll start from this first index, okay, zero. N will be as it is. A will be as it is. Target will be as it is, and coins will also be as it is. Everything is as it is. Okay, let's run this code. You don't need check for I is equal to right, because in some cases are going to come before. Yeah, that is also possible. Like we can have a separate case for that also. It's fine. Like that's also clear. Great. Like this is also a case exactly. We can thanks Rishabh. Like we can have it separate also, and at the last then also. But there will be some cases na. I have to check for I is equal to n, because for I is equal to n, I don't have to go for recursion call. So I can simply write that if I is equal to n, so I will simply return false. Okay, I think that's better. Whenever I will become equal to n, I will simply return false. Like because if it is not clear, otherwise it's false. Okay, that's fine. I think so. Great. Oh, I have taken ARR here. So guys, if I will submit this solution, you will see it will most probably give TLE. Why TLE? Exactly, because it's a recursive solution, or right, yeah, n is equal to n, I is equal to n, exactly. It's 18, it's giving time limit exceeded. Why? Because it's a recursive solution. Now simply what we will do, we will memorize this recursive solution. I will memorize this particular recursive solution. So whenever guys we memorize a thing, uh, you can see that okay, but there is one problem happened. We have to use 3D, like a 3D vector, because there are three things changing in this recursion call. One is I, second is k, and third is target. So I have to take a 3D vector to solve this particular problem. Okay. It's not a 2D DP, guys, it's a 3D DP. Because there are three changing variables. But guys, there is a way, another way to solve this problem. How I can convert this thing into 2D DP. There is a way. There is a way. ठीक है उससे करते हैं let's solve this problem using a different way how we can convert this 3D DP like abhi you can see we have solved this problem completely now let's have a 3D how we can convert it into a 2D DP so for 2D DP guys I will just have a slight change here I is not required I will simply have my n k and target okay now see what I will do okay everything will be same these two cases will be same I will not be there okay so these both the cases are same acha is it clear कि that was a 3D DP वो बात clear है कि that was a 3D DP okay I hope that should be clear now see let's say I haven't taken I here there is no I index that I am taking okay now what I will do is the test case will be same if target is less than 0 or k is less than 0 I will return false if target is equal to 0 or k is equal to 0 I will return true okay now guys what I will do I will take my answer initially as false now for every I from 0 to n for every I from 0 to n I will take a take case so for every I from 0 to n I will take a recursion case and I will take it guys this is how we have not taken I we haven't taken I but we have used the for loop so previous case this I was also in a recursion call every time I is increased here we are taking it in the here now you can see only two variables are changing k and target so now also the problem will be done okay you can see this one is quite slow the previous solution was running up to 18th test case 18th this one is running up to 13 test case by the way that is more like fast actually but then also that was a 3D DP now we'll simply memorize it so I can take a 2D so you can see two variables are there k and target so I will take a 2D vector of this size only so I will take a vector of vector int dp okay I will take this dp first it will be of size k I will take some extra for better thing and I will take a vector target also with vector of int with size target plus 5 and initially all the values will be -1 okay so now simply I will pass this dp with here I will pass this dp vector with here and I will pass it in all the recursive cases. So in all the recursion cases, I will pass it. Now before calling for every test case, I will first check if the value for that particular k and that particular target is not equal to -1, means it is already calculated. Simply return the value of it. And else what to do? Else calculate it and make its value equal to that. That's a simple thing. So now, like memorization is very classic thing that we do a lot. Okay, you can see it's done. Yes, exactly. You can say it's done. Okay, so we have solved this problem with 33% accuracy because we have made two wrong submissions, like not wrong, but TLE submissions. One was with that 3DP, second was 2DDP or recursion, and now this is a 2DDP with memorization. Okay, so this is how we're solving this problem, guys. The time complexity overall will be n into k into target. So So you can see that k into target is the time complexity for the recursion, and in every recursion call we have a loop of n. So I can say that our time complexity is order of n into k into target, and space complexity is order of k into target, because we are taking a 2D DP only. Okay. In the previous case, if I will solve in the previous case, which was a 3D DP, so in that case also time complexity was same, but space complexity will be n into k into target. Like one more extra n will be added because it was a 3D DP, and which will be slow also. Okay, it will be slow also. So that was what we are doing. Okay, I hope it is clear. Hi Manju, hi. Hi. Okay, so guys, is it clear, everyone, how we are solving this problem? Any doubts? Anything you want to ask? Okay, if you want, I can share the code with you guys. uh, Here's the code. You can check it out. Okay, great then. Okay, so great guys. Thanks for this class. I hope it was great. Now let's meet you in the next weekend on most probably on Friday. Till then, happy coding. Take care. Have a good day. Bye. GFG कर लो हो जाएगा.